indicators have been lit.
9, 8, 7, 6,
5, 4, 3, 2, 1. And liftoff at dawn. The dawn of Orion and a new era of American space exploration.
Strong.
Touchdown confirmed. We're safe on Mars.
Well, hello there, space fans. This is Tariq Malik, editor-in-chief of Space.com, and welcome to our first panel here ever, the Summer of Mars. It's a really exciting time. We kind of saw a taste of what's to come in that video there with an animation of NASA's Curiosity rover landing on Mars, almost a good portion of a decade back. It launched in 2012. It landed 6 months later. And now here we are again, no less than 3 missions launching to Mars. I'm kind of there already, as you can see, this month with the United Arab Emirates Hope orbiter, China's Tianwen-1 mission, and now, just in less than a day, NASA's Perseverance rover to Mars on an Atlas V rocket. And we've got a lot to talk about. So many missions going to Mars, more to come in the future. And joining us are 2 really special guests. We have Jim Watzin, NASA's director of the Mars Exploration Program. Big week and month for NASA right now, and for you, Jim. And Jim Bell, president of the Planetary Society, and actually the principal investigator of the MastCam-Z camera on the Perseverance rover. And of course, I'll be your host. We'll have some opening comments from both of our guests today, and some questions from the first 500 folks who had registered for our platform. Thank you so much. But Jim Watzin, Jim Bell, thank you so much for being here today. And I guess Jim Watzin, let's start with you. I know you've got a presentation to kind of walk through. Let us know what's going on with NASA and Perseverance here for Mars.
Well, thank you, Tariq. I'd be happy to do that. You know, the introductory video you showed and the landing of Curiosity, this makes me really looking forward to February, because that's when Perseverance is going to set down. February 18th, mark it on your calendars. So if I could have the charts. And one of the things, you could go to the next chart. You know, you introduced the webinar here talking about all the other missions going to Mars, and 2020 is really a banner year with 4 missions that have been working really hard to go to Mars on this particular launch opportunity. And unfortunately, our friends over in Europe were the first to get hit with the COVID, and with all the countries and travel involved in finishing up that mission, they just couldn't get it done before they had to stand down for the health reasons for all their teams. So they're gonna try again in 2022, but the other 3 missions have been a little bit more fortunate, and we, not that we didn't have to work for it, we really had to do a lot of extra things here with the pandemic, persevere, if you will, and the teams all get kudos for hanging in there and doing that. But as you mentioned, Hope is on their way. So is Tianwen, and now we get our opportunity tomorrow morning at 7:50 a.m. Eastern time. There, we rolled out the launch vehicle yesterday, and everything is looking really, really good. The weather officer is giving us a very favorable forecast, not only for tomorrow morning, which I hope is when we're going to go, but we have 3 days reserved on the range, Thursday, Friday, and Saturday, just in case. And all 3 days, the weather looks absolutely fantastic. So 80% chance of going from a weather perspective. So it really doesn't get any better than that. I have the next chart. So I do want to start off by congratulating our friends here who did successfully launch. And this was a really big deal for the Emirates, this Hope mission, their first foray into planetary exploration, and with a truly international team. Folks from the university systems in the United States, led by University of Colorado, labs in the Emirates, and then they went to the Japanese to launch this first mission of theirs. Here you see an illustration, well, not an illustration, it's an actual picture of the Hope orbiter fully assembled in the clean room before it was stowed and shipped to the launch site there. So it's quite a sizable machine. And they have 3 very, very interesting sensors on it that are going to profile the atmosphere and to put themselves in an orbit. So they're going to get daily global maps of the atmosphere, which is really going to open up the weather science and climate science research on Mars here. So congratulations to them, and the best of luck on capturing that Mars in the late winter, early spring. Next chart. And wow, what a mission that China launched. Not for the tame. They have an orbiter, which has a lander attached, which will be deployed after they get to Mars, and the lander will deploy a rover once it gets on the surface. So hats off to them to getting that system all designed and put together and tested and on its way now. And I was just thrilled to see that be a successful launch, and that the excitement of that kind of accomplishment, you can just see it in their faces. This snippet from the control room is probably too small, but just a universal thrill when you get something this complex. It all comes together and you get it on its way. So my hat's off to them. Next chart. So you may wonder why all this activity for Mars, why all the excitement of going to Mars, and I call it the second friendliest place in the solar system. We have to give Earth number 1 there, but when you look at the landscape of Mars, if it weren't for a little bit of scraggly grass there from this picture from the desert in Jordan, you'd never be able to tell the difference between the Martian landscape and some of the landscapes here on Earth. It has that attraction. We know that it was once a habitable world billions of years ago, probably about 3 billion years ago. And this is an artist's illustration behind there of what the globe might have looked like at that point in time. It evolved differently than the Earth. It no longer has all this plentiful water on the surface. Its climate is not as temperate as it used to be because most of the atmosphere has been swept away. But it really begs the question of could we habitate it as space explorers? Could we find signs that life emerged at Mars when it was habitable, just as it did on Earth shortly after it became habitable? So intriguing questions, and that's what drives the Perseverance mission, and it drives many of the missions that we've flown in the last 2 decades. Can I have the next chart? So this is a sort of family portrait of what we've been up to over the last 20 or so years in exploring Mars. We had a series of orbiters that we sent to do reconnaissance, sort of give us the data from remote sensing to characterize the surface, to give us a understanding of the planet, to create the maps that were necessary to chart our course on the ground, to get a sense of how it evolved, to get a sense for the structure and the evolution of the surface and the character of the surface. But we knew we had to get down to the surface to really do the serious business. We started back in the late 90s, and we sent a rover called Sojourner, which you wouldn't be able to even see it in the picture if you put it alongside Perseverance. It was a little more than a shoebox in size. It could hide behind one of the wheels on Perseverance, but man, we learned a lot when we did Sojourner. We learned how to land on the surface, and we learned how to survive and operate a system on the surface of Mars. So we were emboldened by that, and the MER program was created, the Spirit and Opportunity rovers we sent. And those two rovers were just a landmark accomplishment, both in the technology, the ConOps, and how we learned to drive and navigate on these. We lost Spirit. We got ourselves stuck in a sand trap, if you will, and couldn't get out. But Opportunity continued for many, many years, and we only lost her recently due to a global dust storm that obscured the sun and prevented the solar rays from keeping the battery charged. But they proved beyond any doubt that there was plentiful water on the surface, there was flowing water, and they even found evidence of ancient hot springs. So really stoked us as we started to get serious about looking for signs of life, and could this truly be habitable. And we built the flagship Curiosity rover, which is still operating now, almost a decade after we sent it. And gave us a lot of tantalizing evidence that indeed the building blocks of life may very well have been present. We got some complex organics, though fragmented, we identified. We see seasonal methane releases, lots of intriguing things. So Perseverance, which is on the pad right now, is taking the next serious step on that research. We have tried to reuse the rover. This is the next generation version of that. A few model improvements, but we've equipped it with a whole new suite of instrumentation to characterize in great detail the geology and the context from where we're going to take samples. We're going to cache those samples, meaning we're going to put them in a tube, we're going to hermetically seal that tube, and we're going to leave it on the surface of Mars for retrieval by sample return campaign. And you know, we're super excited to launch Perseverance tomorrow morning, but we're also excited to say that this is the first step of humanity's first round trip to another planet, Mars sample return. So we are in early formulation work on Mars sample return. We partnered with our friends at the European Space Agency, and the sample return mission is planning to go in 2026 and retrieve those samples that Perseverance will gather and return those back here to Earth in 2031. This takes two more missions that have to work in lockstep. The lander I show at the bottom of the chart here, and right above it, there's an Earth return orbiter that our European colleagues are going to be providing. And it's going to do the duties of back and forth. And I'll talk a little bit more about that as we go forward. So we've had 20 great years of exploration at Mars, where we made a lot of progress, and we got the whole next decade planned out already. So very exciting times. Next chart. This is where we're going to go for Perseverance. We're going to land in a place called Jezero Crater. And Jezero Crater is notable for quite a few things. And one is that it had a long-standing, very large lake there, maybe about 30 miles in diameter. And as that lake aged, there's a clear inlet channel and a clear outlet channel for flowing water. And when you zoom down in and look even closer to the location that we picked to go, you have a dramatically well-preserved delta region there. And the geology there just begs exploration. You know, these kind of regions here on Earth hold all kinds of signs of past life, and we're hoping we'll we'll be able to find those in this well-preserved delta region. Next chart. Here's a baseball card, if you will, of the Perseverance mission. And you can kind of get a sense for the kind of instrumentation we have on board. And you can see the coring drill system with two instruments, Pixel and Sherlock and Watzin, one each tacked on either side of the whole coring drill system. That is about 80 pounds worth of some of the most sophisticated robotics we've ever sent to space there. And that has the capability to drill a sample, and as you drill, the sample feeds directly into a tube that's right behind the drill, if you will. And then we essentially pinch the tube against the side of the core sample, which holds it in place. We take it and return it back to the orbiter. You'll see that ring system, labeled caching system on the front end there. That's a turntable. We put the tube back in there. It rotates it into a compartment inside that has yet another robot that will manipulate the tube to the sealing station where it'll be capped off, and then it'll be hung in a rack until we choose the site where we want to put it on the surface for future retrieval. And that site we will be picking strategically for accessibility for the next mission to come retrieve. The Sherlock instrument, the Watzin instrument, the Pixel instrument, the cameras that we have on board, these are all to characterize the surrounding geography and to characterize in great detail the borehole and the immediate surrounding geology from where we take the sample, which really enable the laboratory science to proceed once we get the samples back here on Earth. On the back end of the rover, we have ground penetrating radar. And that is for the first time, we're going to be able to profile in detail the first 10, 20 meters of the surface. And this is important to help us understand how the crust is put together. Just sheer scientific curiosity, wanting to understand how the planet's surface formed and was built. But there's a practical application too. And as we look forward to human exploration, where they want to land much larger systems, heavier systems, it's actually time to start doing civil engineering on our potential landing sites and make sure that the site can bear the weight of these big systems and provide for a stable landing and subsequent takeoff. If I could have the next chart. So I talked a little bit about the samples. So the samples are collected by Perseverance. They'll be left on the surface, probably a group of them spaced apart for easy access by a very small rover, about 2/3 the size of Spirit or Opportunity. We call it the fetch rover because it is deployed from the lander. Its only job in life is to go fetch those tubes and return them to the lander. And our colleagues at ESA are going to be providing that for us. And then we will launch it. We'll put those sample tubes, which are about the size of a, those tubes that a good cigar comes in? They're about that size. And altogether, we'll have maybe 500 grams of carefully chosen sample in these titanium tubes, which will be loaded in a canister, which is shown in the upper right, about the size of a basketball. And that will be sealed up, and that's on the front end of a Mars ascent vehicle, which will be also carried to the surface on the lander. And that will be take that sample canister into low Mars orbit and deploy it. And then we will rendezvous with it with that Earth return orbiter, and we will then capture it. We'll put it in multiple layers of containment. We'll put it into an Earth entry vehicle, and then the orbiter will leave Mars orbit and head back to Earth. We'll deploy it for a ballistic landing in the Utah test range in 2031. So really exciting for many, many reasons. Work through all the system engineering, do a round trip, and get the first planetary samples back here in the labs. It's going to be truly exciting. Next chart. We have numerous technology demonstrations on the mission as well. We try to keep advancing the technologies on each one of our missions to enable better performance on the subsequent ones. And one of the ones that's captured a lot of attention is the Mars helicopter. We named it Ingenuity because it indeed is a feat of engineering ingenuity. Weighs in just under 4 pounds, 1.8 kilograms, just a tad under. Has 2 counter-rotating prop blades on there. And the atmosphere is extremely thin, as we all know, about 1% of Earth. So these big rotor blades spin at 2,600 revolutions per minute in order to generate lift. And we're going to test fly this and see if it flies at Mars as well as it did in the test chamber back here on Earth as we were developing it. It'll carry a couple of cameras, provide a unique perspective. And if this technology works, it opens up the door to accessing very, very rugged terrain in the future, places we can't get to with our rovers. Has the potential to act as a forward scout for future systems and for human travels on Mars. So we're really excited to see this go. This will be deployed probably in the third month that we're on the surface of Mars. Next. Here's a picture of all coming together for flight. These are the 2 fairing halves for the Atlas. On the upper left, you see the flight configuration with the heat shield still not installed. So you can see how we tuck the rover systems up into that back shell, and then we close it out with the heat shield, and we flip it over with the cruise stages down, and that's how it gets stacked on the vehicle. We want all that energy from that launch vehicle, but we don't use all the volume by any means in the fairing. Next chart. And this is what we hope to see tomorrow morning, 7:50 a.m. We got a 2-hour window, and hopefully we'll be on our way. Make our appointment on February 18th at Mars. That's my overview, Trick, and I could talk for hours on it, but you can see it's a really exciting mission with a lot of content.
That's a lot of mission there for sure. I just really quickly, I know we're a day out. I'm wondering how you're feeling, how the team is feeling to be this close now to launch after, it's been 8 years since Curiosity launched, the last rover kind of this size, and now years in development for what is essentially kind of a successor to kind of push that path forward.
So it's been a long grind for most people. It's been almost a decade's worth of work to get to this point here, and the last year or 2 years of a complex system like this, as it comes together and it doesn't quite work the way you want, and you work out the bugs and everything else. The calendar keeps flipping pages, and there's a lot of pressure on the team, and they usually breathe a big sigh of relief when it's all packaged up and they send it off to the Cape. And we were almost able to relax at the end of the winter and catch our breath, and then COVID caught up with us. And so there's been the added stress of the team working through all of the precautions associated with working, and they hung in there. They persevered. We are so happy that Alex Mather submitted that name, and we hadn't run into COVID yet when that happened, but it is so appropriate for the current situation. So they worked really hard, and they were tired, but the adrenaline is running now. The excitement is high, and everybody is just thrilled that we're here at this moment, almost ready to launch.
And I guess that excitement level, Jim Bell, is high with you as well. I mean, you have an instrument on this rover. The Planetary Society has seen not 1 but 3 missions. This could be the hat trick for Mars if everything goes well this week. Can you tell us about the Planetary Society's excitement level for this mission? And I know you have a presentation as well that you'd like to kind of walk us through to know why the whole world, not just NASA or the United States, are looking at Mars.
Sure, Tarek, and thanks for the invitation to participate in this super exciting time. Delighted to represent the 50,000 members of the Planetary Society in more than 100 countries around the world. It's a truly international organization dedicated to education and information advocacy for space exploration, especially solar system exploration. And the society is just delighted to see all this interest in Mars, and as one of the places, as Jim mentioned, in our solar system where we can conduct the search for past ancient life, or perhaps someday in the future extant life in the subsurface. So super exciting. And I have a couple of slides. I'll just go through them relatively quickly. There's some, I know there's some Q&A out there, but if I could just jump to the first slide. Thanks. And just point out, and this is a graphic that Jason Davis and Emily Lakdawala, my colleagues at Planetary Society, have been building over the years. And, it just really points out that Mars exploration has always been a global activity. It's not been just NASA, right? And if whoever's running the slides, could you just advance like 4 times? I've got 4 little boxes. There you go. 47 missions launched to Mars, with another one. I guess that includes our launch tomorrow. So that's exciting. 8 different nations or organizations, collections of nations like the European Space Agency. More than 40% of these missions have failed, and that's a reminder of how hard this is. It's never ever routine in space exploration. A rocket launch is never routine. Am I nervous? Am I excited? Yes, all of those things. What I've described in the past. When we get to this point of getting ready to light that candle, those of us who spent years, and my colleagues and I have, as Jim Watzin said, have spent 7 years on this project, contributing to instrumentation and getting ready for operations. And when you see that thing sitting there on the launch pad, that beautiful rocket, and 3, 2, 1, you feel like dancing and throwing up at the same time. It's just like, it's this crazy feeling. So a lot of these missions have not worked because it's hard. Because it's hard to launch things, because it's hard. Mars is one of the hardest places to land in the entire solar system, just because of that combination of thin atmosphere. You can't use a parachute to get you all the way, but there is atmosphere, so you need a heat shield, and it's really tough. 8 of these missions have been successful landers or rovers, and that is also super exciting. Go to the next one, please. And so here's just, again, another great Planetary Society graphic that you can find on our website. Just this rich history of Mars surface exploration that the world has been engaged in. Super innovative and exciting, and crazy engineering solutions to that thorny problem of entry, descent, and landing, getting down onto the surface. Powered retro rockets going back to the Viking landers in '76, airbag assisted landing, for Pathfinder, for Spirit, Opportunity, sky crane landing system with the parachute, heat shield parachutes, retro rockets that brought Curiosity down to the surface, that will bring Perseverance down to the surface. All of that, just amazing technology. The orbital data that are helping us define, find these landing sites and map the surface. There are 6 orbiters around Mars, 6 active orbiters around Mars, a lot more inactive, but 6 active ones. We might be, adding 2 more very soon. I'll touch on that in a moment. And of course, there's 1 active rover down on the surface, and we might be adding 2 more in February. I'll talk about that in a moment. And these rovers introduce this mobility aspect, right? I mean, Viking landers, great missions. Phoenix, Insight, great missions, but they're one spot, right? And Sojourner in 1997 demonstrated the value of mobility, and it was really amplified with Spirit and Opportunity starting in 2004, and even more so with Curiosity starting in 2012. So Perseverance will join that family of mobile robots that take us from place to place. Surface science measurements confirm orbital expectations. This key in geology and planetary science, ground truth, right? We think we see something from orbit, get down on the ground. Is it right? Yes, in fact, it's right. Or there are surprises that amplify what we see from orbit, but that allows us to take that orbital perspective, which so many of my colleagues are working on, and so many nations are involved with, and it really have confidence in it and extend it to that global view. And the surface science measurements have confirmed, as Jim Watzin said, that Mars had habitable environments. I mean, it's super exciting, right? We know that the climate of Mars now was more Earth-like in the past. It was never really like the Earth, I don't believe, but more Earth-like, warmer and wetter conditions, surface water, habitable environments from the perspective of life as we know it. And that's super exciting. And then, of course, these missions have involved significant public interest, paid for with taxpayer dollars, right? And significant public involvement. Jim mentioned the naming of the rovers. The Planetary Society has been involved in past rover naming contests, and the Society hosts a website with amateur image contributions. People can take the data that's coming down from NASA spacecraft and make their own images and panoramas and artistic products. And we'll do the same thing with the images coming down from Perseverance. So that's super exciting. Next slide, please. Jim already mentioned, congratulations to the UAE, this EMM Hope spacecraft orbiter launched on the 19th, 10 days ago. Everything seems to be going well for them so far, and it's going to be a great science mission. Some spectacular atmospheric science, climatology, meteorology that'll be done on that mission. Next slide, please. And of course, the Society congratulates China and its launch of Tianwen-1. And that's another one that, as Jim mentioned, super ambitious, right? First try to go to Mars. Let's send an orbiter, let's send a lander, let's send a rover. Wow, right? And it's going to be pretty spectacular. That could be one of two new rovers operating on the surface starting early next year. And so, of course, the Society is wishing them amazing luck and good vibes going their way, as well as for the UAE mission. Next one. And then, of course, we're less than 24 hours now from lighting NASA's Candle Atlas V rocket from the Cape, speeding on its way to try to get another rover onto the surface in a very, very special place that Jim talked about, a place where there was an ancient delta, where there was an environment that we believe was habitable long ago. Whether it was inhabited, really, that's the question, right? Habitable is one thing, inhabited, different bar, which is part of the reason why many in the scientific community believe we have to bring those samples back. Because the evidence that we might find for habitability or possible evidence of past life on Mars is likely to be subtle, in my opinion. And maybe we won't be able to make a slam dunk. And so bringing the samples back for scientific purposes and spreading them around these much more detailed laboratories all around the world that can do just super robust, precise measurements on these samples. It's probably the way to tease that information out. And of course, the engineers who were thinking about human missions to Mars in the decades ahead want a lot of detailed information on the material that's there, the dust, the sand, the rocks, etc. These are materials that people will be walking around on, getting on spacesuits, using for construction, habitats, etc. So this is really the first part, as Jim said, first part of Mars sample return. And all of us at the Society, all of us on the mission are super excited about that. So I think one more, just to remind people that one of the resources, NASA has amazing resources. Another resource is the Planetary Society's website. We have a site there listed, devoted entirely to 2020. The Society is the education and outreach partner for the MastCam-Z cameras, the camera system that I lead on Perseverance, these zoom cameras, wide angle telephoto zoom color cameras, and lots more information, including pointers to the great resources at NASA, JPL, and other NASA centers having to do with Mars. So, Planetary Society is super excited about this summer of Mars, and thanks again for having me on the webinar.
Great. Well, Jim Bell, thank you so much for that walkthrough too. It seems like everyone wants to go to Mars these days. I'd go to Mars, but I hear there's not enough atmosphere there. Really, one of the big questions I wanted to ask is why we keep going back. Jim Bell, you mentioned 47 missions over the past. Jim Watson, there's so many more that are coming. Maybe to start with you, Jim Watson, why does NASA keep going back to Mars? A lot of planets in the solar system to try to land on. Why do we keep going back there?
So, we touched on it, both Jim and myself, is that it's so an intriguing place, the possibilities that there's still evidence of ancient life that has evolved and preserved on the surface of Mars. And you say, well, hey, study the history of the Earth and understand how things evolved here, and we certainly have. But the Earth's surface has had considerable erosion and turnover, and the parts of the surface that are accessible, that are 3 to 4 billion years old, the point in time where life first evolved here, there's only 1 or 2, 3% of the Earth's surface that is still that old, that hasn't been eroded away or turned over by volcanic action or tectonic plate movement and those kind of things. When you go to Mars, probably 70, 80% of the surface is preserved just as it was 3 billion years ago. So the evidence is accessible, and that's very unique compared to any other destination in the solar system. We know that the planet was habitable, and the evidence is accessible, and we've mastered the engineering of how to get there and explore it. So when you put all of that together, that is the destination of choice. We can make the most progress on this so intriguing question for humanity. Are we alone in the universe? And we can make the most progress here at Mars.
Jim Bell, as a scientist who has works on these instruments there, what is it about going back to Mars that you look forward to the most with perseverance, and what can that kind of help? How does each new mission help kind of advance that story of what we know about the planet?
Right. No, and that's a great question, and I'll amplify on Jim Watson's reply. There are amazing places to explore all over our solar system and beyond, of course. And there's a relatively short list of places in our solar system, half a dozen or less, where we think that conditions are or could have been habitable for life as we know it. And the question, are we alone, drives us, right? It drives us to explore all these places. And the thing about Mars, it's not that it's better than Europa or anything like that. It's the thing about Mars is that it's the combination of those science questions and the accessibility. The fact that it only takes 6 to 9 months to get there. The fact that we have opportunities to launch to Mars with the lowest amount of energy every 2 years, every 26 months or so. and so the frequency at which we can visit there, bring advancing technologies there, is just higher frequency than going to the deep outer solar system, which is, we should do that too, right? And of course, Planetary Society, big advocates of looking for life everywhere in our solar system. And so it's that combination of factors that drive us to Mars, and also the plain fact that Mars is the most Earth-like place in the solar system, except for the Earth itself. Right? It's not exactly like the Earth, and probably never was exactly like the Earth. Mars is its own place, but we don't know of an environment. We don't know for sure of an environment that is, that has, especially in the deep past of Mars, as Jim Watson was talking about, that had the conditions that we believe are appropriate for habitability. Probably the ocean on Europa is maybe the other place, and we need to slam dunk that one too with the Europa Clipper mission and others that will follow. But at Mars, we've got this now decades of history, decades of rich scientific information, geochemistry, mineralogy, isotopic measurements, that kind of thing, and we'll really put the exclamation point on all that by bringing samples back and subjecting them to the rigors of the much higher fidelity laboratories, so we can subject them to on the Earth.
But yeah, that's a very good case for the red planet. I think you both have sold me, on it. I have a lot of questions. I should point out that we're getting a lot of questions from the viewers who actually registered in advance. The first 500 or so would have a chance to ask questions. Thank you so much. We hit that benchmark in an hour last week when we made that announcement. So we've got a lot of questions to ask. One of the top ones that I've been asked a few times is why everyone is going to Mars now rather than later in the year or whatnot. And maybe Jim Watzin, Jim Bell, you also alluded to this. What is it about this time right now that makes it a good time to go to Mars for not just NASA, but for China, for the United Arab Emirates, and even for Europe and Russia prior to their ExoMars delays? And maybe if you can touch on the challenges of doing that and meeting that deadline in kind of the tenuous COVID-19 pandemic. I know that throws a lot of wrenches into a really tightly coordinated schedule to reach these launches.
So it's a great question. If you look at the layout of the solar system, Mars is the next planet out from us. And the Earth and Mars rotate around the sun at different rates. And so depending on when you decide to chase a neighbor planet, that determines how much energy you need to catch up to its place in the solar system. And about every 2 years, it's actually more like 26 months, Mars and Earth, you envision it as sort of pass by each other. And so the amount of energy it takes to launch from Earth and try to accelerate ourselves out to the orbit of Mars and get to that orbit at the time that Mars is still there and hasn't moved on substantially around its ring, that only occurs, like I said, every 2 years. We can't build a rocket big enough to shoot it in any other point in time unless we spend many years in space transitioning to Mars. And we'd prefer to get to Mars as quickly as we could, to get on with the work that we want to do. And in these opportunities, you can make that transit in 6, 7, 8 months time, as opposed to 2 or 3 years. And so that's why we have a window every couple of years. It only is open for a few weeks. And that sets your schedule. And it really does drive how you do your work, how you manage risk, how you solve problems along the way. You can't lose time. So that's also what makes this an expensive business, because when you have problems, you have to apply extra resources to solve that problem quickly and not slow down the entire team.
And I'm just wondering, that sounds like a hard job already. But when you have to deal with travel restrictions, with social distancing, and a global pandemic, I know that affected the other missions themselves.
Right.
How big of a challenge was that for your team at NASA there?
Well, that was a really big team. Like I said, this past year we were working our way down from maybe about 1,000 people completing their work on the mission, and COVID hit, and very quickly, in just a matter of weeks, in March, we closed down the various field centers at NASA, and we moved to a situation where we had a transition to virtual work environment. People had to work at home, and it was only by rare exception we allowed people to come into the field centers, to their offices or to their laboratories. And then we had to take precautions to sanitize all those buildings, to do the social distancing, to provide protective equipment for each of the personnel to finish their work, the hands-on labor, and connecting to the systems that only resided at the labs. And then we had to work on our hardware in the field. So we had somewhere on the order of 80 folks out at Kennedy doing the last 3 months of assembly and testing and getting this stacked on the rocket. And they had to sort of sequester themselves from life all around them. We had to come up with transportation to and from the West Coast for the people, to try to keep them out of public airports and off of the airlines. And people that were out in the field had to spend a longer time in the field away from their families, rather than go back and forth like you usually would do for a 90-day or 100-day type of field campaign there. So it took a lot of dedication and commitment on the people, a lot of extra stress on everybody managing and planning and adhering to it. We had to get extra space on the center at Kennedy so we could spread people out. You know, when they weren't in the clean room doing the work and they were in the office environment, we had to get more office space and spread them out. When people did show up, we had to quarantine them from those that were still there. So lots and lots of extra steps associated with that. And it really was a burden, particularly in the beginning until folks kind of understood it and it became a little more normal and natural to deal with it. And then of course, just the routine things after work, you like to be able to go get some refreshment, something to eat in the local environment became a hot spot. And so folks couldn't even access that. So it was a bit of a sacrifice, but as we like to say, the team persevered. We couldn't be prouder of them.
There's a couple of technologies on this mission that that are a bit exciting that I don't think we've seen before. Jim Watzin, you mentioned the helicopter, and then I did hear earlier this week that there's some microphones that same Jim Bell have a legacy with the Planetary Society about kind of recording actual sounds of Mars, both from the landing and then also from the rover itself. And I guess Jim Bell, to start with, kind of what is that microphone there, and how did it begin, or its inception at the Planetary Society?
Yeah, so I mean, the idea of a microphone in the Martian environment goes back at least to Carl Sagan, one of the founders of the Planetary Society, and even earlier. And part of it is scientific in that you learn something about the speed of sound in that atmosphere, and you learn something about the interaction in the case of Perseverance's microphones, the entry, descent, and landing system and its engineering, the laser spectrometer and its interaction with the surface. While the Planetary Society doesn't have any direct involvement in the microphones going on Perseverance, we tried in previous decades several different efforts funded by members of the society, at least partly, were on missions like the Mars Polar Lander and others that just were not successful. And so the other part of the flip side of that coin is there's just massive public interest in hearing the sounds of Mars. What does it sound like? Does it even sound like something as a dust devil or dust storm passes over the rover? Can you hear the little sand grains that we know are pelting these vehicles from the Martian winds? We hear the rovers themselves, the wheels, the gears, the map moving around, just hearing the sounds of the vehicle entering the atmosphere, deploying the parachute, it's going to go, that entire sequence will be recorded in audio as well as video for Perseverance. And, assuming we survive the landing, we can downlink that data and have some of the most amazing movies ever taken in the space program. It's going to be spectacular. So there's both the scientific side of it as well as a strong public interest and public engagement side of that, and that's why the Planetary Society is so delighted that we're able to accommodate a couple of microphones on Perseverance.
That's amazing. Yeah, and not only will we hear those first true sounds then from Mars. Jim Watzin, you mentioned we're going to have a helicopter flying if all goes well with Ingenuity. I was reading that there's an oxygen generation experiment that I'm sure astronauts would be interested in later on to make air on Mars. You're going to test spacesuit materials there too. So it's a lot of other types of work there. A lot of the technology that you've packed into this rover, that it makes it seem much, much more than a simple sequel to the Curiosity rover from 2012. Is that about right there?
That is correct. Yeah, we had the good fortune to be able to add some technology experiments to this mission. We had the capacity to carry them. And as Jim was talking about, we have 2 microphones on board, and we'll record sounds of interest for the engineers and sounds of interest to everybody just as a human to see what it's like entering Mars and working on Mars and what that environment, it just feels like. It's increasing our senses and our presence. We have over 20 cameras. We've added a lot of engineering cameras. Technology on small miniaturized high quality cameras has gotten to the point that every major stage of the entry, descent, and landing system has cameras either looking up or looking down. So what we see in animation, we'll be able to validate with photography now and see just how well those systems do perform, and also the excitement of experiencing entry, descent, and landing with visual and oral senses. We have the 2 cameras on the helicopter. So, gee, what a perspective now with the landscape as it flies over the landscape doing its test flights, and as it looks back at the rover from altitude. You know, that is just going to be
not too close.
Really,
not too close.
Yeah, really stunning image there. Moxie is our oxygen generation experiment for converting CO2 into oxygen. So it breaks down CO2 into carbon monoxide and oxygen. And it's a proof of concept of a technology that could be used to generate not only oxygen for human consumption and for survival, but also to generate, produce fuel. We're also looking forward to the future, having experiments where we can tap into some of the near subsurface ice and see if we can extract that from below the surface and use that to create oxygen. And the ground penetrating radar that I mentioned it earlier on is going to start profiling the surface so we get a better understanding of what it'll take to get down to that ice after we get a good map from it from our next orbiter. So we have lots of technology on board. All of these are looking for enabling greater accomplishment and even bolder performance on our future missions.
Well,
and as Jim mentioned, engaging the public too. I mean, it's so great that the public is so enthused about it. We're flying 11 million names on this rover to Mars. We open the door for people to say, "Hey, I want to ride along," and we put those on chips, and those chips are on board, and they're flying with us.
No, that's great. I think I have a boarding pass for this mission.
Yeah, great.
In some of the past, I should
Better
point
get
out
down there quickly. You're going to shut the door without you.
And frequent Mars miles, I believe. And there are links I should point out on NASA and the Planetary Society. You saw that Jim Bell had that link on how to get involved in at nasa.gov. And also be our virtual guest. There are programs there for the public to not just follow this mission, but get involved and celebrate as well. And speaking of the public, I do have a few more minutes and a few questions from our viewers. And one of the first ones is for you, Jim Watzin, from Carol Marsh. She's interested about this mission and how it will lead to the first astronauts on Mars, and what is a realistic goal right now for when the first humans could set foot on Mars based on these missions?
Well, that's a great question. Where you look at the past 20 years, the evolution of our capabilities at Mars on the surface, and you look at where Perseverance is going to take us, we're actually going to, as I call it, collect some souvenirs at Mars. And with joining it with the sample return campaign, the next 2 missions, we're going to take that round trip journey to go from Mars and go back home. And that's absolutely essential before we fly humans, is to make sure that we understand all that's involved operationally and engineering wise to make a round trip. So we're making progress with the robots, and they inform the designers of the human systems. And what we have planned coming up later this decade is going to be a huge contribution to enabling the human space flight, which folks are looking at potentially in the 2030s. So when you look at NASA's plans, what we're doing with the rovers and learning to do at Mars and learning how to come home from Mars, and you marry that with the operational experience and the system development for life support and transporting the crews that's going on with the Artemis program at the moon, the next couple decades are going to be really exciting, and hopefully we'll see the first astronauts at Mars.
Yeah, there's a question just for you, Jim Bell, from DB2. With all of those exciting missions happening now and coming in the future. What do you tell someone, maybe like a kid or a student or someone that's looking to get into space exploration for a career? How do you advise them to kind of get into that the field? What should they study? What should they pursue? What should they be even thinking?
Oh, it's a great question, and the answer is there's room for lots of expertise in space exploration. It is not just follow this one path, get a PhD, whatever, right? There are so many ways to get involved in and contribute to space exploration. Engineering, every single kind of engineering, mechanical, computer science, software, electrical, long list of kinds of engineers are all over these projects, and because they present super difficult problems that need to be solved, and engineers love to solve problems, right? And so many different branches of engineering, many different branches of science, geology, meteorology, chemistry, geochemistry, physics, biology, all of these and more are important in both robotic and human exploration of our solar system. So there's ways to get involved that way. Educators, just teaching people about what is our solar system like? What are these? How do we learn about our own planet by studying other planets? Education, big part of what NASA and organizations like Planetary Society are trying to do. So there's roles for teachers and other educators. And then if you look at how these spacecraft are built and operated, there's a supply chain, just like anything else, and you can go all the way down that supply chain. We're building cameras, but somebody built the circuit boards, and somebody built the resistors on the circuit boards, and the tiny optics that go into the lenses, and this huge involvement of the commercial world, commercial space, but also just the commercial technology world. So any of these companies that are small businesses, large aerospace firms that are involved in this activity, that's another way to get into the space program. So I tell kids, work on your foundation, your math, pay attention in chemistry class, physics class, and get to know some engineers, get some mentors. Think about all these different possible paths, but work on building that foundation and your connections and your networking. Networking is hugely important in for any job situation. But don't think to yourself, gosh, I don't want to go down this. I don't want to be an astronaut, or I don't want to go down some traditional path. I'm not going to be able to get involved, because it's not true. Because I'm sure Jim Watzin has the same experience. People from all walks of life, every possible career path, are making important contributions to all of these missions.
That is great. That's great advice, not just I think for kids, but for all of us, right? To make for whatever subject you want to pursue.
Yes, journalists and media people are making contributions to. I mean, you're helping to get the word out. You're telling the stories. This is really important. This is almost everything that we do is publicly supported, and people have to feel both a strong sense of ownership and a sense that they're getting a great return for their investment, and that's what we're all working towards.
Well, it's really hard to believe that an hour has gotten away from us just talking about Mars. I feel like we could keep going for another hour. I did want to leave some time for some closing comments. I think, Jim Watzin, you had a slide you'd like to share about what people should be looking for, not just for tomorrow's launch, but for the landing 6 months from now, and the years hopefully to follow when these missions continue. Jim? Watzin?
Yes, thank you. Yeah, if you could put up the last chart. Yeah, I want to kind of leave and just touch on the human spirit aspect of all of this. There's excitement in all of this kind of work. There's inspiration that we find in this kind of work, and there's the perseverance to just work your way through struggle and get to the other end. not only survive, but also to succeed. And, you know, the whole coronavirus thing has sort of brought that to a head. And I talked during this webinar about how some of the things that we had to overcome and some of the sacrifices the team had to make. And I want to bring back, you know, the young man, Alex Mather, was the winner of the naming contest for the rover. And he wrote an essay and recommended perseverance. And that so well captures the spirit of space exploration. It so well captures the spirit of society as we struggle through any kind of issues, and the struggles of individuals and people through our personal lives and the things that we have to do. And he just had a essay, which I encourage you to go Google and look at it. And I've taken a snippet of it. And he said, you know, we picked some really inspirational names in the past for our rovers: Curiosity, Insight, Spirit, Opportunity. And all of these rovers they describe qualities that we possess as humans and we saw as positive and encouraging. And so we had selected them and assigned them. But he pointed out that we've missed one of the most important ones, that as humanity, as humans, perseverance is key to anything that we think is important, anything that excites us to drive through the challenges. And that as species of explorers, which we intrinsically are, we'll meet setbacks all along the way, but we persevere and we never give up. And I think that reflects the hard efforts of the thousands of people that have contributed to this mission, the thousands of people that contributed to the other missions that we saw launch in the past couple of weeks here, and society as a whole as we figure out how to deal with this pandemic and take care of each other and come out the other side. So it brings out the best of us. That's one of the things I really like about space exploration and working in the business, is that bring out the best in people. And I hope we pass on some of that positive sense of encouragement as we go fly our missions.
Well, thank you so much, Jim. And Jim Bell, any closing remarks there? It is a very inspiring mission, inspiring time to go to Mars.
Look, I totally agree with Jim. I mean, you know, we've all become familiar with the heroism that's going on among first responders, law enforcement officials, our military. And it's a different kind of heroism that's happening in NASA and their contractors who are helping to keep the space program going, helping to keep us, you know, looking up and wondering and answering the deepest questions, despite all the problems that we're going through here on our little planet. And I think that is incredibly inspiring, and I draw energy from that kind of heroism as well.
Well, thank you so much, Jim Bell, president of the Planetary Society. Jim Watzin, director of NASA's Mars Exploration Program. Thank you both to us. Thank you all for watching us here. We're very excited. And I would like to remind you that these missions are exciting as they launch, but this is just the beginning for them all. So mark your calendars for February 2021. That's when Perseverance arrives, when the Hope orbiter arrives, and when China's Tianwen-1 arrives, and Perseverance will land that first helicopter on Mars, look for samples, and set the stage for sample return in the future. So thank you all for joining us today. A very special thank you to our guests from NASA and the Planetary Society, and all the best for the launch tomorrow. Thank you.
Thanks, Terry.
Thank you so much for having us.